All right, here's some probability review. You can find this sheet on LMS. It's called Master Review, What is the Probability? If a problem says anything about what is the probability, or a random variable, or a standard deviation, or a mean, it probably, your answer is probably on this sheet. But I'm going to go ahead and walk you through a bunch of this stuff. If we remember probability, the probability of any event. Remember, an event we write with a capital letter. An event is anything that can happen when we do some type of test. So if I roll a dice, an event could be an even number. But for any event, the probability is between 0 and 1. For the event I just described, rolling a dice, the probability of getting an even number is 1/2, which of course is between 0 and 1. So the probability of an event is equal to 1 minus the probability of the complement of the event. AC, or A prime, means the opposite of A. So if my event is getting an even number when I roll a dice, the probability of getting an even number is equal to 1 minus the probability of not getting an even number. Another way of saying that is probably getting an odd number. A couple other words: mutually exclusive. Mutually exclusive means that they cannot happen together. So if remember, A union B, A combined with B means probability of A plus probability of B. If two events are not mutually exclusive, this becomes the probability of A plus probability of B minus the probability of A and B. If two things are independent means knowing the value of one does not affect the value of the other. If they're independent, you do probability of A times probability of B. If they're not independent, it becomes probability of A times probability of A, or B given A. These formulas are on your formula sheet, which I will also attach to LMS. These last two equations have to do with random variables. The mean, or the expected value of a random variable, means you take all the things that can happen, multiply them by the probability that they happen, and then add them all up. You'll remember we have some tables. We multiply across the table and then add up all those values. The standard deviation, to get the standard deviation, you would go into lists and you'd make one list the probability that it happens, and one list the things that can happen, one list the probability. So if we're talking about a dice, we'll use the easy example of a dice. Let's do one. The things that can happen are 1, 2, 3, 4, 5, 6. The probability that any of them happens is 1 divided by 6, 1 divided by 6, 1 divided by 6. Oop. 1 divided by 6, 1 divided by 6, 1 divided by 6. So we have two lists. This is the formula for standard deviation. I don't expect you to use that ever. To find the mean and standard deviation of this random variable, right? The random variable is, I'm going to roll a dice and see what number comes up. I can click stat. I can go over to calculate. And I only have one variable. I'm only rolling one dice. My list is L1. The frequency is L2. Calculate. It spits out all these numbers. The expected value, or the mean, of my random variable would be 3.5, which means if I rolled a whole bunch of dice, I would expect the average number to be 3.5, and the standard deviation is 1.7. So those are general probability rules. If we zoom in down here, if you do a problem that says what is the probability, it may also give you more information. If the problem says that it is normal, then you will use one of two things. Normal CDF, which we all know how to use at this point. You draw the curve, you draw your lower and upper bound. You say normal CDF from here to here. If you don't know, remember 1 E 99 gives you the top value. You put in your mean and standard deviation. The other thing you can do if it says it's normal is use your rule of thumb, which says if you go from your mean 1 standard deviation out, you get 68% of your data. If you go 2 standard deviations out, you get 95% of your data. If you go 3, you get 99.7. So again, this is if the table, oh my gosh, tells you it is normal. If it's not normal, you're not out of luck yet. If it tells you it's normal. If it's not normal, you might find that it's binomial. For it to be binomial, it has to follow bins. If we remember, bins means binary, independent, number of trials is fixed, and S is same probability every time. If that's true, the probability that your random variable equals some number is binom PDF. Probability that it's at most some value is binom CDF. Probability that it's at least some value is 1 minus that. Remember, that's bins. Might also be geometric. If it's geometric, it's BIS. We say we don't know if it's bins. We don't know the number of times we're going to do something. We call this the waiting game, or until. Moving forward, what formula should you use? Kind of with that, is it easier to calculate what I want, or is it equal to calculate the opposite of what I want? Remember, you will always use this if it tells you will do 1 minus. If it's the opposite of at least 1 is 0. So if any problem tells you to find the probability that at least 1 of something happens, it's almost always easier to calculate the probability of 0 and do 1 minus it. But if it says and, this bracket over here is and. If it says and, your equation is what we talked about up here. The and equation is this, close to this. It's this. Probability of A and B is probability of A times probability of B given A. If I know A happened. If they're independent, it simply becomes this. Problem may also ask you to calculate, may say or. If it says or, you're using this formula. Probability of A or B equals probability of A plus probability minus that they both happen. If they are mutually exclusive, so if you know they can't happen together, A and B simply becomes 0. So this equation becomes probability of A plus probability of B. Last one it may tell you is given. Oop. Given. If it's given, we're talking about probability of A and B. So probability of that A happens if I already know B happens. Probability of A, this becomes, if we rearrange some stuff, probability of A times probability of all these formulas are here, right? This is your OR formula. This is your given formula. To find probability of A and B, you simply multiply this over. You can switch the letters. Find probability of A given B, you do probability of A and B divided by probability of B. Another question you should ask yourself if the question is about probability is, should I organize my data? Should I do a table? If you do a table and you want your expected values, that's what I walked you through already. The more useful one is a tree. If your things happen in sequence. So if, for example, there's a question on the AP test about testing positive for the coronavirus, right? Let's pretend 50% of all people have the coronavirus. So you would start a tree where you'd have a person. There's a 50% chance they have it. There's a 50% chance they don't. Then if they have it, there's a certain percentage chance that they test positive. There's a certain percent chance that they test negative. Same thing for the people that don't have it. To find the probability that you test positive, you multiply all the branches and you add the test positive branches. So trees are a good organization method. Lastly, we're going to talk about combining variables. If you multiply by a value, the mean changes and the standard deviation changes. When you multiply the mean and you multiply the standard deviation. If you add to the mean, you do not add to the standard deviation. If you are combining variables, so you have two different random variables, the expected value or the mean of them, you simply take the average of X and you add it to the average of Y. For standard deviation, we combine it using the Pythagorean theorem. So we do the square root of the standard deviation of X squared plus the standard deviation of Y squared. There's a problem in your homework where there's 4 random variables. Find the expected value of all 4 of them added up. You would simply add up all their expected values. To find their standard deviation, you take the standard deviation of each one, square it, add them all up, square root it. If you have a normal distribution with a sample size, there's a problem that we talk about getting into a boat. A boat can only hold so many people or so much weight. It says in that problem, it says that the average person weighs 180 pounds. Actually, I think it says 190 pounds. It says the standard deviation of any one person is 10 pounds. Then it says, what's the probability that 4 people exceed 800 pounds? Well, 4 people means we're going to multiply by 4. So the mean is going to be equal to 190 times 4. Standard deviation, we are going to multiply by 4. But now we have a sample size of 4, right? If we come over here, if we take a sample mean, right, our standard deviation of the whole thing would be 40, but our sample size is 4, so we have to divide by the square root of 4. Well, thankfully, the square root of 4 is an easy number. It's 2. 10 times 4 is 40. Square root of 4 is 2, so we do 40 divided by 2, and we get 20. If we combine normal random variables, the whole thing will be normal. So now we have a normal variable with a mean of whatever this value is, standard deviation of 20. We want to know the probability that that variable exceeds 800 pounds. This sounds a whole lot like this type of problem to me, a normal CDF.